The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family member was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Wednesday, October 26th, 2022. We're a day early because there's a community meeting happening tomorrow in Pahala, so hopefully you guys are catching us with our scheduled announcement. If not, then we will be back on our normal schedule next week, we believe, unless something else pops up that we don't expect prior to the week before. Dane, what do you got for us today? Nope. Nothing yet? Give me some voice.
There we go. Was just going to say, yeah, just wanted to point out again that we're not going live because anything special is happening at the volcano, but due to a scheduling conflict. And we will be back to our normal schedule next week. Great viewing at Kilauea yet again. So, we'll look a little bit at some pictures, but again, the talk right now is still about Maunaloa, so we'll be spending most of the time on that. I think we should just get right into it, huh?
Sounds good, yeah. Let Dan know if you have any issues with our audio or video, and he'll be leading the discussion in the chat and answering whatever he can there. And otherwise, we will stop after our Maunaloa segment here for a round of questions. So, all that said, we'll get into it here. By starting out with our Hawaiian volcano summary. And this is a view of Maunaloa at a sunset that Dane caught for us here. It's still quiet up there, not a lot going on above ground. Below the ground, I compiled this summary chart. I've compiled the last month of earthquake data, earthquake counts, with a little bit of the month before that, just so you can see the whole pattern really here, right? And the idea is that we are back to close to background levels of earthquakes. We're about the same levels as we had back in early September. Not to say it's going to stay this way, but for now, the earthquakes seem to have quieted at Mauna Loa. The volcano still seems to be filling with lava. We'll talk about that. But it's doing so without actually stressing itself and causing the earthquakes to relieve that building pressure. So it's still filling in, but not as much building pressure. That's the long and short of it there in Mauna Loa. For Kilauea, viewing is still good. As Dane mentioned, here's a little clip preview of what I'll show you guys a little bit later. Shot from Kanakakoi Overlook this past week, showing lava still visible in the persistent lake, spattering. There's glow from the area, various areas, and so we'll recap that for you guys as well. And as far as Kilauea's data story, here is the tilt plot from the last month, and this gives us the summary of what we have going on here. And that is that we have lots of deflation and inflation cycles happening, and the volcano was inflating for much of the month before this is the offset caused by the earthquakes in the flank of Mauna Loa. About a week after that, we now seem to have a little bit of a deflationary pattern on Kilauea. So Kilauea is actually slowed down. No longer swelling on a short term. This is long term is different, of course, as are short term variations. But that's the story. A little temporary slowdown in Kilauea is what's happening this week. So, having said that, let's switch ourselves over here to our Maunaloa reports. And USGS put out this report today, and here's the data at the top, and they're putting out Kilauea Mauna Loa as a single document now. So I'll scroll down to the Mauna Loa part of it. And as you can see, we're still at alert level advisory, aviation code yellow. And just to remind you guys, this is unchanged since July of 2019, right? Over 3 years of an unchanged alert level. For the USGS, refer to maybe like yellow plus and yellow minus kind of thing, but we're still all within the yellow. And that major alert level that triggers other actions by the county and state has not changed since July of 2019. So not erupting, no signs of an imminent eruption, and really state of heightened unrest continues. Really, there's not a whole lot of information that's new in here because a lot of it's been repeating itself day after day. We're down at 20 earthquakes in the last day previous to this report, and tiltmeters at the summit not showing significant surface information over the past week. Everything else low, SO2, all the gases and thermals and all of that. So that's the report from today. However, I thought I'd step back a couple of days to the report from Wednesday, and let me maybe scroll this up if it'll allow me here. So this was put out Monday morning, 8:47 a.m., which was just about 12 hours after there was an earthquake on Mauna Loa summit, which initially was reported here on that following morning as a magnitude 3.1 earthquake occurring at 8:35 p.m. Sunday night at a depth of 2.5 miles, 4 kilometers below the summit. That puts it right around sea level, but definitely deep underneath the summit, in that same area that magma's been filling within the volcano. And importantly here, they note, this earthquake caused a small step excursion in the data stream at MOK tiltmeter. Okay, so let's look at that. And we'll actually scroll past the earthquakes to start here. We'll come back to these in a minute, but here is our tilt plot for the last week at the top. And the green and blue are two different components, pointed in slightly different directions at 90 degrees. And what you're seeing is the line is actually right here. I'm going to zoom it in so you guys can get a nice good view of it there. You're seeing the blue line is jumping up and then resuming its trend, and the green line is dropping down and resuming its trend. And so this is a classic example of this step offset that you get with earthquakes when it moves straight up or straight down rather than actually inclining, kind of growing. And if it goes at an angle, then it's more likely to be something slightly more gradual, and then it's not an earthquake. Earthquakes are instantaneous. So that's what you see there. However, if you look beyond that, let's say we try to take this and glue it back onto here, you might still see that there's a bit of a rising trend here happening, right? That kind of seems to be, if you mark either the tops or the bottoms of these daily cycles here, you see a little bit of that pattern. It's not quite clear how much it is, how much is being influenced, and how much of other cycles are embedded in there, but it does appear that the signal is showing inflation still at the mountain. Now, you can't really see a whole lot in a 1 month tilt because of the flank earthquake spike is so huge, it's throwing off our tilt scale here on the left. And really, the little wiggles, you can see the inflationary period that followed the seismic swarm at the end of last month, beginning of this month. And it pretty much stays right around that zero. for almost the whole way until we see this step over here on the right, which we just talked about right above. So really, long term, it hasn't changed a whole lot. If anything, it's maybe showing this little inflation coming in more recently here. And that's not unexpected. We talked about last week about the cycles of the earthquakes and the filling of magma, and how when an earthquake releases pressure on a flank, it actually can trigger some injection of magma into the volcano through the normal conduit system, and it can fill more passively after that. But kind of that's the cycle. It fills and pushes and fills and pushes, and it's all about whether it does it passively or whether it has to erupt to get the pressure relieved. And so far, just like it has for really, especially the last 10, 15 years or so, it's been able to do that more passively without having to build enough pressure for eruption. So a little interesting curiosity there, really, more than anything else. This little offset that could alarm you if you're not really quite sure what you're looking at there. But really, the more interesting thing here is this rising trend that you see coming before and after. Looking at the GPS is for the last year here, across the summit north to south on Mauna Loa. And so you see, if I'm zooming in all the way to the right side here, this was when it was getting further apart. You see the distances getting the length between them getting greater very quickly with that steep line there. And then you see it's still going up, but it's not coming up at quite the same rate. So it seems to still be inflating. And for this year-long plot, we're probably looking at the last month somewhere right in here or so, right? So since those earthquakes, it seems like we're still filling, but at a slightly lower rate. And there's a lot of variability in here, so you can see scatter in the data points, and that likely means there's a lot of adjustments on a small scale that are kind of adding to the noise of this signal, right? Keeping in mind that this north-south distance is an inner crater measure rather than the whole zone that swells, so it swells outside of this also. So it's kind of funny. It can move swelling from slightly more north or slightly more south, and it can affect the signal even if the grand scheme of things is all still swelling. All right. The up signal that's just measuring up, you can see it's still rising here. This is the MLSP station. And scatter is normal, as you can see, going back in time here. The important thing is the trend still seems to be coming up, right? So it's still getting pushed upwards and getting pushed outwards, meaning it's filling in from below. Right, so for the last 5 years, here's what it looks like now. Our most recent little adventure was right over here. And you can see how that compares to the one we had back in early 2021 and late 2020 right in here, right? So you can see a much bigger signal we had in the past. And in case you're curious when that alert level went up to yellow, I'll pull it back here so you guys can see July was somewhere right in here. So you can see that before the volcano was extending slowly still, and then it seemed to pick up in late 2018 following the Kilauea eruption. And by mid-2019 is when USGS raised the alert level to advisory yellow, and since then it's really been continuing much of the same trend. You can see it was going faster, and if we look more closely, you can see that they actually have several of these little adjustments. There's one there, there's one there, there's one there, and then the big one here. And then you can see that this is probably a second one over here that actually never came back up because the volcano had reached a steady equilibrium there. And from that point on, it's been rising a little more slowly, right? And then now, within the last few months here, we can see it's starting to pick up its pace a little bit more, getting a little bit steeper for its rise. Haven't quite matched what we saw here in 2019. Maybe we're getting there, getting pretty close. Certainly see the same pattern, a little wiggles, but you may see more of these little flank adjustments and possibly a bigger one that comes. And just a reminder, this last one did not cause an eruption either. So we can have even bigger adjustments than what we saw and not have an eruption still. So that's why we're at alert level yellow, elevated above a background still, but we're not in a state where we believe that the volcano has to do anything eruptive, right? It can still do this passively, as I was saying before, filling inside and stretching and adjusting without having to build pressure to erupt. Similar pattern on up for the last 5 years here on GPS. So there is that. I thought I would pull some of these figures out of the talk that was given at Ocean View by the USGS and Civil Defense last week, which we were honored to participate in. So what we have here is at the very top, a combination of distance, north and south, similar to what we were just looking at, right? So what we just saw, that this last plot right over here, pull it up here a little more. This zone right here, this 5 years right there, and comes from flattish to a little steeper, a little bit of wiggle, but still coming up. All that fits into right in here. Right in there. That's the whole 5 years right in there. And so if I zoom it way in, maybe that looks a little more similar. But you can see that overall, the pattern is going back in time. It's not very fast, this extension. You can see it's been done that before. Here's prior to that 2019 alert raise level, and back to 2014 and 15 back in, 4 and 5 back in here. And prior to that, you can see we're contracting, and you get some little wiggles and change still, but nothing really dramatic. And to give you some frame of reference, here's back to the eruptions in 84 and 75, and you really expect, in this case, they were talking about something like 40 centimeters of extension across, right? Half a meter of extension as that eruption approached. So that's a much larger scale of change there, and you can see that we are changing, but relatively speaking, it's kind of unimpressive at the comparison, right? So not to say we shouldn't be prepared. We'll talk about preparedness more coming up here, but that's just something I wanted to pull out from that talk. Moving on from there, we have a map of GPS vectors. This is data from April to October 2022. So this is a fairly recent window here, and this is showing swelling due to the influx, right? So if you haven't seen these plots before, I'll remind you how they work. The actual station is at the base of any one of these arrows, like somewhere right in there. The length of the arrow indicates the magnitude of motion, and this little black oval at the end of the arrow indicates the error, like how much uncertainty there is. So some of these, you can see this is a fairly certain data point like this one. Others like this might as well be close to nothing because it's such a large error there, right? It's pretty small and uncertain there. But you can see that over the last 6 months or so, we're seeing a zone of swelling, what is being termed moderate, perhaps, question mark, Mauna Loa inflation. And you see it's limited to this upper summit region right through there. Possibly could do a little bit less circular and cut through something like this, and it's not quite clear how you would do that necessarily, but you get the general idea through here. Just the upper part of the mountain is what's been swelling. And since it was shown in a presentation, I thought I would do the same here to compare that same plot we just saw in Mauna Loa over here on the left to what's happening on Kilauea. So here's Kilauea, and here's how much motion we've had in the last 6 months on Kilauea. So as you can see, this amount of motion on a volcano is pretty normal. The arrows might look big, and it's all about how you scale it so the map and graph can be seen here. But really, we're not seeing anything unusual on Mauna Loa compared to what we see normally on Kilauea here. And that's the long and short of it. We'll come back to this Kilauea part of the GPS when we come talk about Kilauea after our break here. There's a lot of cool stuff in this part of the map as well, but we'll move on from it for now. And just to round it out here, we have a recent Insar capture, 1 year's worth of data. We're not getting exact dates here, but presumably it's fairly recently. And what you can see is this butterfly-shaped pattern. There's one wing and there's the other wing right there. And that's typical of what you expect for a dike-like body that has like a blade or a sheet that's somewhere in that orientation like that. Right, so that's consistent with that model we've seen in Mauna Loa, and it's how it's a rift zone, and this dike is a large part of its magma storage system at fairly shallow depth. So that is Mauna Loa's monitoring data that we have here. So let's see, next from that, we will move on to the earthquakes on Mauna Loa. Load those up here. Mention this pattern already, that before, looks like 17th of September right in here, we were at 20 earthquakes per day or lower, and the USGS update reminded us when we first had this event that the background was 10 to 20 earthquakes per day. So it went up a little bit on the 17th, but it really went up on the 23rd, and then on the 29th and 30th here. Those are the peak periods, and that elevated background, that maybe we'll call it around 40 earthquakes per day, that persisted for a while, even longer than the main swarms that occurred at the end of the month. And until the 20th, and the 20th was our last update when we talked about that small little cluster of earthquakes up at Mauna Loa Summit. That was this. So almost like a a late adjustment that followed that flank movement. And since that happened, zooming in here at the right end, we're down mostly below 20 earthquakes per day again. Right? It hasn't been quite a week yet, but it's notable that that's been the case here, and we'll have to wait and see what happens. And as we said, this is a cycle, so at some point you'll see it ramp back up and do something similar again. It's unclear if that's going to be days or weeks or months, right? It probably won't be longer than months, given the pattern we've seen in the last few years here. That's the earthquake pattern, and just to tie it together, here is a last month plot, and this is the right side of the graph I just showed you guys. That's the same thing right here. All I did was just add on a few days so you could see the start of this from the other side here. So looking at the last year of earthquake data, you can see here we've come down from our high of almost 500 earthquakes in 1 week. The weeks before and after, we're at 300 earthquakes per week right in here. There's our 500, there's the 300s, and 200 was last week, and this week is still in progress, but it does not look like we're quite at the same rate there as before. So we'll see this peak likely continue to come down a little bit, and we might end up close here, but definitely it's coming down. If we go to the last 5 years, and now we're counting earthquakes by month, we haven't finished our month yet. So this is going to be a high month once again, and really be the next month that we'll expect to see this trend come back down again. Right? Similar to what you saw here in 2021, it was spread out over 3 months in that case. Here we have a similar pattern over 2 months, but there you have it. That's the big picture of earthquakes. Looking at the map for the last week at the summit area, you can see earthquakes are still ongoing. Here's that northwest cloud, summit, and upper southwest rift, all still seem fairly active over the last week. Now, for comparison, let me scroll down here for the last month, so you really can see that it's come down quite a lot. It still hasn't stopped. It's still adjusting, continuing the same pattern as we saw before, but in a lot lower numbers recently here. And let's go to the main earthquake map here, and I can show you guys what this looks like. So the yellows are the last 2 weeks, and orange are the last 2 days. Red, if there were any, would be in the last 2 hours. So at this exact moment, there are none in the last 2 hours, but there are a few here in orange, 1, 2, 3, 4, 5 that I count, and the rest are in the last 2 weeks there. So if I were to change the settings here and go back to, let's just go back to the last 1 day, see how few earthquakes we're having per day under the summit that are actually even showing up on this map. So we had a lot more on this map because this one is counting all the small ones, the less than magnitude 1 and sometimes even very small negative magnitudes there. So as far as larger earthquakes, these are them. Here within the last 2 days, the largest was a 2.4, 1.4 kilometers above sea level, 2.1, 1.9 kilometers. These are all not that deep, fairly close to the surface, and adjustments above that magma injection zone that we have. So the reason I had this back on the 7 days, let me pull it back to that here and have this sorted by largest magnitude. So we can select this 2.9 here. A little more on the screen. So that's a 2.9 that occurred at 8:35 p.m. on Sunday night, the 23rd. That's the one that was originally reported as a 3.1. You can see it's been revised down to 2.9, and a depth is 0.1 kilometers, so pretty close to sea level still. Right, and that one occurred right there under the summit. And you can see that 2.1 that followed that we just mentioned is very closely related to that one as well. So likely pressure is just propagating up through the stack of rocks there as the magma below has been pushing and pushing and building that pressure. So that's the pattern of Maunaloa. Really not a whole lot of earthquakes. That's the highlight one right there that caused that tilt offset. And zoom it out a little more. You see there's a few in the flank, but really not a whole lot of activity on Maunaloa itself. You see most of this is all yellow, meaning it's not happening very recent. In fact, if I once again come back to the 1 day all magnitudes here, you can see that even this Pahala zone is a little quieter than we've seen recently. So those are the earthquakes there, and to pull it all together and put this in the context we established last week, here's a little cutout of that cross section we made. showing the relation of the Deep Pahala earthquakes over here to the flank earthquakes over here, and the summit earthquakes that have this extra depth on the west side, but really it's a larger mushroom cap right above it. And so the earthquakes we just saw, like that 2.9 earlier, 3.1 was right in here, propagating its way upwards here, right? So same zone, same cloud. I will pull it back to here's the last 2 weeks of data. So I'm not showing the background anymore, but you can kind of see the pattern here, taking off all the whites. In the last 2 weeks, we've had activity. There is that flank activity. There's a Deep Pahala activity. And here is the summit activity, including that stuff to the northwest, the northwest cloud kind of right through here. And fast forward it to the last 2 days, here's what it looks like. You can see there's almost nothing happening on the flank. Still an aftershock, right, of that sequence we had a couple weeks ago now. Still some summit events. This was I screenshotted this earlier when it was still red and was still within the last 2 hours earlier today. And still having some in Deep Pahala over here, right? So, but in comparison, not nearly as much flank adjustment anymore, and not nearly as much summit adjustment anymore as we're having before. And to see it a different way, let's put it against time. So time on the bottom and depth now. Surface here, there's sea level. And so this down here, this band down here is the Pahala cluster, disconnected from anything shallower there. So it's been going off normally. It's really kind of independent of everything else going on. This up here is our flank. I'm sorry, this is our summit adjustment here. Initial flurry of summit earthquakes. This over here is the flank. Right, so you can see the flank activated, maybe not as up and down, not as with the same, maybe it wasn't a stripe vertically like this as this indicates. Might have been clustered more in this lower part. You can see the bigger circles are right down in here. So really the activity at the flank is this strip right through here, really, right? So you can see it started off with a bang and a lot of aftershocks, and here's one we had today, but it seems like it's really quieting off significantly, right? And there's a shallow zone once again. See the shallow zone that we saw early on. Here is that event we had last week at the summit, and you can see that is also slowing down there. Zooming it in to make it a little easier to see, there's just the last 2 weeks. You can see in the orange and the red how sparse they are, especially in this upper part of the volcano here. Pahala still happening, maybe not as much as before, but independent and disconnected here. Disconnected at the scale that we care about, because we've shown the connection back here. It does exist. It's just a deep, long connection all the way around, so we're not really feeling much of that, right? That's this disconnected zone right through here. So that is the earthquake data, and I thought I would finish off this earthquake segment with the last week of Mauna Loa's summit webcam. Day and night, you see how clear it is up there. You see the clouds flying by, and the sun coming up. Don't see the moon as much this cycle. You see some stars flying by there, but really pretty quiet and beautiful, and not much evident on the surface of Mauna Loa there. Okay, so that's just about all the data from Mauna Loa today. But before we take a break, we're going to talk preparedness, right? Because that is our theme. What people are buzzing in the community about what's happening with the earthquakes and what that might signify and what do we do and all of that. So we will spend a little bit of emphasis on Mauna Loa preparation. And starting off with what the USGS said, we're just going to restate what they presented here. What's happening now at Mauna Loa? There is small inflation at the summit and upper southwest rift. There is above background seismicity at the summit, upper southwest rift, and on the flanks, maybe quieting down a little bit now, but still, generally speaking, that's ongoing. What are we missing? This is the important thing here. We are missing consistent and or persistent seismicity, and we are missing increasing rates of deformation and seismicity, right? So we need to see it, you see them rising faster and staying elevated for longer, right? And potentially continuously all the way. So that's what we're missing. We're seeing, we basically would describe as an intermittent pattern. And we saw a flurry of earthquakes, but it's wound back down and intermittent. What is HVO doing for preparedness? So they're adding and upgrading all their webcams, including thermal, upgrading our gas sensors, installing additional GPS coverage, doing a lot of planning with emergency response personnel, right? Coordination planning with National Park Service, Civil Defense, etc., and internal planning. I think as much of anything, what we're seeing now is this flex, right? The Hawaii County Civil Defense and USGS really getting out there and doing community outreach way ahead of time, right? Not just with Volcano Watch, but public presentation, community meetings here to really address this public concern that has come up because people aren't used to feeling that many earthquakes in that area. And it makes you wonder, especially when the alert schedule, the update schedule has changed, and the backcountry summit of Mauna Loa has been closed by the park, and Civil Defense is having these meetings. So, you know, it's really just showing the organization rather than showing that something imminent's about to happen, right? Now, because there is so much hazard in the area, you really got to be preparing when nothing is happening. So when something actually starts happening, it's too late to prepare, right? So that's why it's important to emphasize this preparedness aspect right now, even if we're not seeing the imminent aspect of the eruption here. And along those lines, I thought I would show this again, since Frank Truesdale showed it one more time as well. The same cartoon back from 2002, eruption is not imminent, after the volcano scientists, where there is a slight swelling, and the news media going nuts, eruption is imminent, right? We could substitute the tags today, right, for something more current, right? Packing go bags or something along those lines here, but it's basically the same pattern, which, as you can imagine, is not all the truth there, right? Hopefully that's why you guys are here. So, speaking preparedness, the lava is something we want to prepare for sure. The lava, when it erupts, whenever that is, even if it's years from now, is going to flow downhill and it's going to impact some area directly by the lava. It's going to likely cut off a highway. It's going to impact the whole island with traffic and flow and all that kind of thing like that. But those are, relatively speaking, fairly small zones of impact for the lava flow itself, right? And Dane has mentioned this before, talking about his analogy of a roulette wheel, and it's really wherever the wheel stops, like that's where you have your zone of impact, and it's not the whole island all at once, or all the sides of the mountain all at once. However, as we just mentioned up here in this first slide from the USGS, what are we missing? Consistent and persistent seismicity and increasing rates of deformation and seismicity. So if we are going to proceed to an eruption, or whenever that happens to be, we should expect more increasing rates of seismicity, more consistent and persistent seismicity, right? So what you're telling you is, before there's likely to be an eruption, there's likely to be a lot more earthquakes, right? So why don't we talk about earthquakes a little bit? Because that's really perhaps something that we could all take to heart and prepare for a little more, seeing as that area has a history of big earthquakes in the past. So I just thought I'd pull up this Volcano Watch. This is from 2 weeks ago now, October 13th, just because I really liked the impetus for preparedness, right? Volcanoes and earthquakes do go together a lot of times, and preparing for both, there's a lot of commonalities you can do there. The point being that just because you don't think the lava is heading for you perhaps doesn't mean you shouldn't be prepared for earthquakes. There's a much bigger area of risk and impact there. So this is an update to the Hawaii National Seismic Hazard Map from 2021. And plotted on here are earthquakes larger than magnitude 5, going back to 1840. Right? So they have yellow as the older era, orange is the more recent, 1900 and 1959, and 1960 to present is in red. Right? So this is the state map, and you can see that almost all these earthquakes are down here around Hawaii Island. Maui's got a good amount over here too, and Molokai, Honolulu have some too. But ignoring all that for now, zoom in on Hawaii Island here, and you can see that this zone of Kau has a lot of these big earthquakes right through here, right? So that's the concern really right there, is how many big earthquakes have occurred historically. And let's look at this in a few different ways. Here's a map that's actually plotting the different fault lines, right? The surface extent of faults that are known on a volcano. And this is not necessarily all of them, and maybe they're not all as active as each, one is maybe not as active as another. But it shows you weaknesses in the rock and how these volcanoes have created these weak zones as they adjust to each other. So Kilauea is down here on the side of Mauna Loa, right? And it's pushing back on Mauna Loa to some degree, and Mauna Loa is pushing this direction here, and so that's where it catches and why it's having these earthquakes in the flank. The flank isn't just sliding freely like Kilauea's can, or at least it's not doing that at present. If it does that here, it's going to bring Kilauea with it, actually, right? Riding on top. So the point is, you can see how many potential zones of adjustment exist with these fault lines right through here. Zoom it in so you really can see well. Right, the red is a rift zone, and these orange are just other faults that can move as the flank adjusts here. I'm not scared of lava coming out of these cracks here necessarily. That's more the red ones, but these are areas you could have these earthquakes, right? So this 7 and 8 are earthquake epicenters from these big earthquakes in the 1800s here. Moving through a little more. Magnitude 6.0 and larger earthquakes since 1868 on the island, a different way to look at this. I like this because it's showing in red the earthquake fault rupture areas. That kind of shows you the possible footprint of these earthquakes. It's not just necessarily where you see them in the past, but the whole geologic structure that's causing them, right? Which gives you a better idea of where they can actually occur. So, Kilauea South Flank. I don't know if you'll be able to see my red across here, but it's that square right in there. And that's what just moved in 75 and 2018. 89 and 08 as well. That's what we saw adjusting there. But you can see that Mauna Loa's south flank is all of that, includes Kilauea all the way to the tip. And Mauna Loa can set off Kilauea's south flank as well. And that's the zone of all these big earthquakes, especially right here on this side, right? You can see there's other areas as well. Here's that Kona flank that has earthquakes as well. There's one on that south side of Hualai, north side of Hualai. But really, of this picture, you can see that right here is, if you were to pick one zone to put a bullseye on, that would be where it would be. So that's the area we're talking about. So good reason to be prepared for earthquakes, to get everybody, not just those by the rift zones here. So there's a few different ways that this has been plotted. This is going back to 2014, and this is showing seismic hazard, and I won't go through to plot what the scale actually means here, but you can see that, relatively speaking, the red is a higher threat than the yellow, right? So they have a similar pattern here of earthquake hazard being more so on the south side of Hawaii Island, and decreasing to the north side of Hawaii Island, and then decreasing to Maui, and then further over to Oahu and beyond, right? That gives us a relative idea on Hawaii Island. I thought I'd take it one step further, because in 2021, this has been redone to make it consistent with the rest of the US. So by the most recent 2021 map, here the highest chance is this dark red, and you'll note that our entire island of Hawaii is in dark red, and in fact all of Maui and half of Lanai, it looks like here, right? All Kaho'olawe, all in this dark red. And if you go to this light red, you even get Molokai in there as well. It takes to get to the orange, you got to get all the way to Oahu to get to the orange and yellow, and Kauai to the green. So this is basically saying more than 90% chance of a slight or greater damaging earthquake in the next 100 years, right? That's pretty much guaranteed there's going to be a damaging earthquake in the next 100 years. But the reason that this was redrawn, so you actually can see less detail on the island, is to make it more consistent with the map for the rest of the country. So let me show you guys that here before we ease into our first break. Here is the entire US, and it's a slightly different scale once again, but if I zoom into Hawaii, you can see that more or less there is a dark red, there is a light red, there is the orange, and there's a green. So it relates close enough, right? So you can see that other areas of red: Puerto Rico and US Virgin Islands, southern Alaska, the Aleutian chain, and you can see California and Seattle on the west coast. And you also get some here in Idaho, Wyoming area right here, right? But relatively speaking, much of the rest of the country is nowhere near that light or dark red. You do have this New Madrid fault zone here, Mississippi as well, but story for another day as well. In any case, relatively speaking, Hawaii has one of the highest earthquake hazards in the entire country, right? There are other areas that are comparable. You can go to Puerto Rico, you can go to Alaska, you can go to California, but that's the ballpark that Hawaii is in, right? It doesn't really compare to anywhere else outside of those zones for the most part. Right, so that is the earthquake hazard, and without going into too much further detail, we'll kind of leave it at that. Earthquakes are something maybe you can all be prepared for a little better, but this is what civil defense is putting out. If you want to be connected to the alerts, here are the different ways that they're allowing signups through Everbridge, through emergency alert system. There are sirens and radio messaging as well. And of course, each community has got different challenges, and so that's why so many different ways to try to be connected here. All right, so couple of final things here on Mauna Loa before we take our break, and transitioning into our community corner, just to kind of let you guys know what's happening in the community here. Give a Hawaii Tribune Herald credit here. I haven't seen this reported anywhere else. Pahala Library has been closed for quake repairs, and here is the free tag here. It's been temporarily closed after 2 earthquakes in the flank damaged the building October 14th. This is a paid story, so I'm not going to show it to you guys. But the long and short of it is it's not structural damage. It's ceiling tiles, and it's closed until they can get over and fix them and replace them and clean everything up. And that's the long and short of it. Maybe about 2 weeks-ish. You have to wait and see. Go and read the article on Tribune Herald if you want to get the rest of the scoop. But notable that there was a little bit of damage there. Thankfully, not structural. Yeah. Otherwise, in the community, the reason we're doing our update today instead of tomorrow is because tomorrow, 5 to 7 p.m. at the Pahala Gym is another Mauna Loa volcano status update and community discussion, attended by Civil Defense and USGS-HVO, Talmadge Magno and Ken Han leading those efforts there, and we will be in attendance as well down there. Right? A couple final things here in the park. We're finishing up October. So there's only a few things left on a community calendar for October here. Kind of scroll through. There's still stewardship going on. There's still walk in a pass with Dr. Jagger going on with our friend Dick Hirschberger. Otherwise, we've passed everything else except for Every Kid Outdoors Halloween weekend. That's happening Saturday the 29th at the main Kilauea Visitor Center, main park area, or on Sunday the 30th between 10 a.m. and 4 p.m. at Kahuku Unit. And you get a scavenger hunt bingo card, explore the trails, and you get your bingo card filled out and come back for a treat bag. Right, that's October. Coming up in November, not that far out, there is Be Free Veterans Day, November 11th. There is stewardship going on Fridays and Saturdays, and alternate days of the week, different weeks. The Walk in the Pass with Dr. Jagger continues on Fridays. Kahuku has the birth of Kahuku. This is the geology highlight of next month over in Kahuku. 90-minute hike, 1.5 miles. Saturday, November 12th, 9:30 to 11 a.m. This is part of the Kahuku series. And then they have, as part of their Kahuku Coffee Talk series, Saturday, November 19th, 9:30 to 11 a.m., Birds Not Mosquitoes, with speakers from American Bird Conservancy and Nature Conservancy about that initiative. Following that, on the 22nd, we're back to our After Dark in a Park series that we hope to continue streaming for you guys with a collaboration of Two Pineapples. Mahalo, you guys. Is Rapid Ohia Death Talk by JB Friday, Extension Forester UH, and National Park ecologist Stacy Torrigo. Then the last Tuesday of November, the Aloha Rodeo with David Woolman, talking about the Paniolo and the 3 Hawaiian cowboys that competed in the world's greatest rodeo. So that's the events for the whole next month here. That wraps up the first part of our update today. And with that, Dane, I will pass it to you.
All right. We will start off by recognizing some of the supporters that we have and make this stream possible. And then we'll get into some questions that we have lined up. First, I'd like to thank Gary Bryan, longtime supporter, showing up in chat with $35 super chat. Says, thanks very much, Dane and Phil. Thank you, Gary, for that continued support. Also want to acknowledge our sponsor, iCare Hawaii. iCare Hawaii has bunch of different services that you can take advantage of. One of the main ones is the the same day glasses, right? So you can go in and get fitted, get examined, all that, and get your glasses and lenses in the same day. But they also do a bunch of eye care, so like LASIK. They do disease management for like glaucoma. So they kind of have like a total package thing going on. Definitely check them out, and they are supporting our Mauna Loa segment. They want to keep an eye on Mauna Loa, and we are going to, ensure that happens. So we appreciate the continued support for our new sponsor. I mean, not continued, but our new sponsor, Eye Care Hawaii. And if you got any concerns or you need to get some glasses, definitely check them out.
Mahalo, you guys.
We also are brought to you by the Wi-Fi grant, which is from the County of Hawaii, and we appreciate them. This is providing this content. It ensures that we are able to provide a year worth of these updates, as well as updates in text, and work with other community organizations. So we really appreciate the County of Hawaii and the Wi-Fi grant program for making this all happen. And I think with that, we can get into some questions, huh?
Yeah, let's do some questions.
All right. We got a good one here. We have several good ones here. We'll start with this one from Hawaii Rasta Lady asks, there's been a lot of tremor during the last 3 days on the DAND and the RCOD seismographs, southwest rift zone, the upper southwest rift zone of Mauna Loa. Can you show us and explain what's happening, maybe?
Maybe. You're asking me to
we'll see if
use my browser with a USGS site while going live is a little bit of a challenge sometimes. So let's give it a try.
I can send you the two pictures if you want.
Yeah.
The two,
okay.
What do you want? 24 hours or 48?
I like to see the 48 hours usually. Let's see if I can find them on here. That's the WRD. There's our COD. Okay.
I don't know. It looks like it's working for you.
Yeah, looks like I got it here. It's the past 48 hours. It looks like it's kind of quieted down today. Seems like whatever was going on seems to have ended around midnight last night there. And you see the peak of this activity there was in the morning of the 25th, and go back a little bit more. You see, it kind of comes and goes, and could be some tremor in there. For comparison, let me pull up here one of these Summit instruments. Let me go to all the way up to MOKD. Past 48 hours and see what's happening up there. So on this plot, it's a little different, yeah. It's a little less continuous. When you see it more spiky like this, I don't know if that's a proper way to describe it there, but it looks a little more spiky, these signals. That's usually when you get wind, or it could be small earthquakes, but more than likely this is, given the pattern and the size or distribution like that. That looks like a small earthquake, like right there. That looks like a small earthquake, for example. The pattern is fat on one side and it tails off to the end. But a lot of these other ones do not look like that, right? That looks like it's probably just some rock bouncing around on the ground kind of thing. So
this
that
is
makes
noise.
me suspicious of wind.
A lot of noise.
Yeah, it makes us suspicious of wind as the main, when one comes up on seismographs a lot. Let's go down here to the dandelion. And it's not as clear here. So I can't really discount that there could be some tremor, and we have seen some signals in that upper southwest rift, and I did just say that the volcano is still filling with magma, right? So it could still be filling with magma and moving through that reservoir underground, and it could be causing some tremor too. But even if that's the case, on its own, it's not like it's causing any earthquakes, and it's not causing any surface deformation and beyond what we've seen already, right? It's actually a little bit less. I didn't quite go through all the GPS stations here. Let's see if I pull those back up and come back to the GPS here, and if I show you guys, there's the tilt up at the southwest rift at Sleeping Cave, 10,000 feet, and showed you guys that this signal has been rolling around a little bit, kind of rolled up and rolling down. So I imagine there is some movement underground there. It's part of the system after all. But what I find interesting, if we dive into it a little bit more, here's a 2-year GPS Ainapo trail. You see that the north component seems to have stalled a little bit. The east component seems to have stalled a little bit, and so has the up. Right? So this is up at 12,000 feet and 12,140. Similar pattern. It seems like it's slowed down. Not quite as clear, but definitely an up seems to have slowed here in the last month. Which is to say that the effect of this swelling that we saw on the GPS like over the last 6 months maybe is contracting a little bit, so it's still swelling, but not over quite as broad of an area as it was a month ago, likely because the flank adjusted here recently, right? So the flank adjusted, it made more room inside the summit area. The summit's likely filling with magma, and that could cause tremor. So it wouldn't be surprising to see some tremor. But once again, we'd expect it to be intermittent and not continuously persistent, right? Which would be more concerning there. And wind is also intermittent. So in some ways, we can kind of hedge our bets there and say that it was something intermittent, and whatever it was doesn't seem to be escalating to anything else major there.
All right. Next question is from Richard, and it's kind of going to go with another question, so I'm going to do both of them, if you don't mind. Richard asks, are Maunaloa and Kilauea's chemistry different because Kilauea system gets more water injected into it? And then Bill asks, can Phil address the process of chemical differentiation of the magmas from different mountains, rift zones, etc.? Is there some depth at which the magmas are the same? So we're kind of just talking about the whole system from depth.
Right. So let me pull up this cross section we had from before, because that might be useful to draw on here, right? Okay, so
yeah,
deep down in the hotspot, the magma is thought to be mostly all the same stuff, right? But there are different pathways that come up. So as magma comes up through these pathways in Maunaloa, whether it's this way in Kilauea or kind of drew it to be over this way, they're taking different paths. And as it's moving through the rocks along those different paths, it can actually pick up the traces of the chemistry of those rocks. And those rocks happen to be slightly different over here than they are over here. And that's one of the primary ways you actually get a difference in the chemistry of the lavas. It's only in a trace chemistry because really it's largely all the same stuff from the same source. So part one is that it's coming through different pathways, and those pathways pick up different traces, and that gives them their unique chemical fingerprints, right, that make them distinct from each other if you can analyze them to that level of detail, right, which takes instrumentation. You can't do it by hand. So it's more so the pathway rather than water, right? And the water is kind of a whole other can of worms of where water sits within this structure and this cross-section and all that. But there is water under Maunaloa and in parts of Maunaloa as well. It's just certainly not the same exactly as Kilauea, but there is some water in there as well. Water can have an effect. But interestingly, there's thought to be a difference in the CO2 output of the volcanoes, because there is a little bit of a difference in the distance here, right? So it seems like somehow, I don't know if I have, let's see if I can find this figure over here and pull it up real quick. There's paper by Gonerman that talks about the connection of Maunaloa and Kilauea, and it goes through that, especially the CO2 offset. Almost got it. Just throw that on here real quick. All right, so it's thought that I believe the CO2 rich plume comes out of Kilauea and the Maunaloa CO2 poor. That's not quite the image I thought it was right there. But anyways, there is a difference in the gas content, perhaps because of the different pathways coming out. So that's another part of the chemistry that's a little bit different. Now, as far as so that's Richard's question. As far as Bill's question, chemical differentiation, that occurs because the magma is not coming continuously all the way up all at once, right? It's moving to some zone upwards, and it kind of parks itself where it finds neutral buoyancy. Then it can move upwards again. It can park itself again. It can move upwards, and it can park itself again. And in fact, that's where it's parking, this uppermost section today. That's where it's filling, and essentially parking itself there. At every one of these stops where it's parking itself, and Kilauea similarly, the magma can separate the crystals that are formed within it. So often that's olivine, so you're crystallizing olivine in a magma. And if the magma stays stopped for long enough, that olivine can kind of settle out of the magma, and that changes the chemistry of the magma to make it less olivine rich. We'll call it for simplicity here.
Right.
Now, obviously, it's got to be separate, and nothing else is going to be coming into it. If something comes back into it, it's just going to reset it, and it's going to be what it was before. So there's two components there. One, it has to kind of stay parked, and two, it has to not be replenished, right? So usually you don't see that as much on Kilauea or Maunaloa, unless you're on one of the far ends of the rift zones where the magma doesn't get there quite as often and gives it time. So the most recent example we have is Fissure 17 from 2018 eruption that erupted down in Lower Puna. It erupted explosively, it was booming all the time, and now we know it was an andesitic basalt eruption from that area. And because that magma had a chance to kind of stay isolated and settle out, differentiate, and that kind of made the magma that was left a little more silica rich, a little bit more sticky, able to hold gas a little more, so that rather than just kind of billowing gas out like a smoke signal like we see from Kilauea most of the time, it instead started going poof, and like the periodic explosions that you see from other volcanoes with that more sticky magma, right? So I hope I've covered it there. I mean, there's a lot of detail and all that. You can take a whole course in geology on this, right, and go through all the graphs. But so I am trying to keep it simple there.
I think we even have like a 1-hour presentation on that, this on the hotspot and everything as well.
We do, and then there's the whole 2018 eruption chemistry. There's a whole presentation on that, and how in one case study of how different magma came through, and the hot magma took a while to come all the way out, and so you saw like 3 different kinds of magma throughout the eruption of all different histories, right? And that's kind of the simple version as well, because you can go and get more complicated than that too. We'll leave it at that.
Right.
But that's overall the process.
Got a question from Ernie on Facebook. He asks, how's it, my brother? In Hilo, are we safe from Maunaloa activity at this time? I get choke ohana and Kona. I just need to know choke generator sales going on the past 3 weeks. Let us know where to be for evacuation. You have any comment on that? I mean, we get a lot of those types of comments as well thrown our way. So what is your thoughts on those, on that like type of thing?
If I was in Hilo, I wouldn't be worried. If I was in Kona, I wouldn't be worried either. Right now, we do live in Maunaloa, and should be aware of the hazards, right? And as I said, you're more likely to get hit by an earthquake than you are with a lava flow. If lava does go towards Hilo, there's going to be weeks to months of time ahead of time. Plenty of time to buy generators, whatever else. If you got to order one, then again, if you need one, go ahead and take the deal, right? Yeah. Similar for Kona, right? The places that I would worry more about eruption affecting at this point are Maunaloa Observatory and Puhakaloa Training Area, the ones that are actually within reach of something from the summit, because all eruptions historically have started at the summit and usually stay at the summit until some later phase, right? Which may come years later potentially, and we'll leave it like that today. But so Hilo and Kona, more worried about earthquakes than I am about lava flow anytime soon. Now, Ocean View, I'm worried about earthquakes also, but because they're so close to the rift zone, and just on the odd chance something unexpected happens, right? You should be ready all the time for eruptions, but being prepared and being worried are two different things, right? And so I would encourage being prepared, but I would not worry about it at this point, right? Unless worrying is what makes you get prepared, then get worried so you can get prepared. Be prepared.
Star asks, what are the dangers and risks associated with something like a magnitude 7.0 earthquake somewhere on the south side of the island? Like, what are we talking about?
Stone buildings, usually stone walls, will collapse. So if it's a rock wall outside, no big deal. But if it's part of your house or some historic church, then that's likely to crumble. Stuff's going to fall off the walls, fall off at high shelves. And depending how heavy a stuff you have and where you are, you don't want it falling on you. That could be dangerous. Usually wooden structures will bend and sway, right? And so long as everything's nailed and fastened properly, that's all good. But if you have some rusty connections, for example, then those might separate, and you might have some structural damage based on that. If the earthquake's big enough, you can expect structural damage kind of across the board, right? Worst case is if the earthquake puts an upward force that exceeds 1G, right? That means that anything not embedded in the ground will fly off the ground with the force of the earthquake. Now, there have been instances in the past of houses in Pahala that were just on post and pier, not strapped to the pier, actually jumped up and landed off to the side. So you don't want that happening. Those are the kind of things, especially more the historic houses that maybe don't have the modern standards of construction is what you'd worry about. But because there have been so many earthquakes in the past, there's probably not a lot of those left, to be honest. Still some, because as you guys know, driving up and down the island, there's plenty of old houses all over the place still. Many not occupied, but those are kind of the hazards really there, right? And so there was just the great shakeout last week preparing for earthquakes, and so stop, drop, and cover. We can go through all of that maybe some other time, but that's the basics of it.
I mean, if the only thing I can maybe add is if there was a big earthquake like that, I would be hesitant to go across bridges until they were assessed with anything that was heavy type things, right? Just exercise caution, and because we saw in the 2006 earthquake, the Kīlauea, just how damaging that was to some of the infrastructure, especially the roadways. So if we got bigger, it potentially could get more damaging for select bridges. So yeah, just be careful in the immediate wake until those things are assessed and figured out by the proper authorities and all that.
Landslides too. Yeah, landslides
along
too. Those lines. Yeah.
Yeah.
Could come on a road especially and block the road or all. So.
Yeah.
Actually, you can't feel an earthquake, and if you're driving a car, unless it's about bigger than a 6 something, right? So if you actually get something 6.5 to 7, you actually will feel it while driving, believe it or not. Anything smaller, you often don't. But start feeling the ground shaking while you're driving. Stop the car.
We have 2 more questions for this segment, and then we'll go on to Kilauea, I think. These are both good questions. Chris asks, the GPS lateral and vertical expansions are very small, 3 centimeters or less in the last year. Given the scale of Maunaloa, are those dangerous amounts or innocent amounts of growth?
Those are innocuous amounts of growth. Those are not dangerous amounts unless the mountain can expand. And if it can expand, then it starts quaking, right? So we actually saw the first sign of it not being able to expand for the first time in a while, first time in over a year, just recently. But it stopped doing that, so it expanded. So it did expand, and let's see, over the last 20 years, the mountain has spread by 4 meters. It's opened 4 meters. So 3 centimeters in that time, it's really nothing, right? It's normal. It's normal. That's what I've been saying for the whole last month, right? This earthquake swarm and adjustment of the flank, this is normal. We've seen this before without it erupting, and we're taking a chance like everyone else to preach preparedness and to educate people because as you've been saying, Dane, the more educated people are, the less concerned they are as we talk to people around the island here, right? It's really, if you're, that's hopefully that's what we're getting across to you guys is there's a lot we can learn, a lot we can understand. We should be prepared all the time, but not really that concerned, honestly. Right.
Got one last question here from Star. It asks, are some of the HVO personnel, and I'll include, we can't really speak for them, so we'll just say, including us, even though we're not HVO, are they put out by all of this and feel it's too early or overdone panic by the public? Or let's even include the media in that. Right?
How about yes?
Yeah. I tried to make a meme of it. Like the along the lines of that comic, right, that Philip showed earlier, and even that was misconstrued when I tried to put it out to past internal screening. It was some people thought it was hilarious, and then I tried to put it out a little bit into the public, and it was like, okay, this isn't taking, right? The hype is still real on the Maunaloa thing. Like yeah, but it's good though to take advantage because we are going to have to prepare for all this stuff, and it's like, hey, if this is what God has to be to in order to get people to prepare for the next one. It's like, all right, we'll do it.
Yeah, so it comes back to what I just said recently, right? Like if people knew more, they wouldn't be as concerned. So they must not know enough, right? So we have more work to do, and we have more to talk about it. And hopefully all of you guys listening to us now can go and share with your neighbors and spread the word, right? And because the thing is, someday this mountain is going to erupt, and it's going to erupt somewhere near people, and we're going to need to put out a warning and be taken seriously, right? And so we can't be crying wolf at every little jerk of the mountain, right? Like, we'll know when it's time. This is not it. This has never been it. This could be the start of it, but it's not it, right? So it's got to do more than this for it to actually, be convincing. So
yeah,
that's I don't know.
We know it's going to do it one day too. It's like we're just it's a dance, right? You want to keep people prepared. You want them to be aware of the thing, but you don't want to be that guy that basically cries wolf, because there eventually is going to be a wolf. We know that wolf exists, right? It's a very big wolf. It's just its shadow scares people all the time though, type of thing, and that's not helpful either.
Well, the reason we do this is we're scared, right? We're scared that long term we're not ready. Not so short term. I'm not scared because I don't think it's coming short term quite yet. But long term, I know for sure we're not ready. So I am scared long term. That's why I keep saying preparedness, because we have a lot of work to get there, right? At individual level, I think at the county level as well, we have a lot of work to get there, right? Given some of the interactions at the meeting this past week. So sometime we're gonna have to have warning and have everyone take it seriously, and every one of y'all who's crying wolf now is getting dinged and losing trust of the community, right? And so you're losing your credibility and reputation by doing that. It's all you, whatever, but we take this seriously, right? And if there was a reason for us to put out alert, we would. The USGS would certainly as well. And that's not the case, right? I think it's important to note that the job of Hawaii County Civil Defense is to prepare for the worst case. That's what we want them to do. We want them to prepare for the worst case, be ready for the worst case, and act like the worst case is coming all the time. By all means, please. But as a consequence of that, they talk about the worst case almost exclusively as well. That's their job. But that's what to prepare for. That's not what to expect. Right, and so USGS is caught up in this a little bit too, because they're the ones feeding civil defense information to cause them to. So they're kind of caught up in that as well, right? So we will take the stance of stating what the worst case could be and stating what you might expect that's not the worst case based on history and a context and perspective. And that's that latter part why we're not worried as much in a short term, right? And everyone's got their role to fill, and civil defense is doing what they have to, but it's just, that's a challenge. It's a challenge for them to prepare for the worst case and come out to public meetings and talk about that, and people think the worst is about to happen naturally. So that's a challenge as well, beyond just the media.
All right, I think that will do it for Maunaloa. I'll try to answer any other questions or save them for the end if I cannot, and we will continue on to the next segment. At your command there, Phil.
All right, so we're going to switch to Kilauea, and since we're talking impacts, we'll come right into the volcanic hazard summary as a first aspect of Kilauea, because the gas coming from the volcano is still the largest impact to our communities. The fog that's blowing through downwind communities, and we've had slack winds over the last month, so it's been coming into other areas as well. However, the most recent data point we have is all the way down here to the right. 700 tons per day is the lowest we've seen in a while. It definitely upholds this downward trend we've been seeing over time. So really, the big picture of the gas is the gas seems to be decreasing, right? And so we may still get some points coming up here. So it might not be this straight and this steady of a decline. It might bounce around a little more first. But it's undeniable here, the pattern of gas actually dropping down over time. Right? So you gotta wonder if that's something to do with the measurements, since it's a much wider area now, or if the gas is getting mixed into the lava beneath the crust and not as much as bubbling out of there. That's another possibility as well. or if it's just hard to measure coming across 300 acres, as it might be more dispersed. In any case, the most recent measurement is down, which has brought some relief to the island here. Here's the most recent VOG forecast from the VOG mapping project from Hawaii. Hawaii.edu, and you can see the point source right here, and VOG staying mostly in this area southwest of the volcano, right, and wrapping around Maunaloa a little bit here to the north, and still southwest part of the island. But overall, it's not really blowing over to Hilo or to the saddle like we've seen as much recently here. So let's go to that purple air and get this to load. It has to load fresh every time. It doesn't like to remember where it was. So here we go. Pulling up the citizen science sensors. Okay, so let's start in volcano. Here we're at 0, but if I click on this, it'll give us a plot for the last bit. That one's showing zeros all the way across. I'm gonna click on the other one, and what's gonna happen here is it's gonna start stacking all these plots on the same graph. So that one's showing us coming up to 2. What's that? ppm perhaps. So let's go down to Pahala here. And now it's coming up to, oh, not quite 10, but we're still in a green. Down to Kahuku. And you see some higher values coming up through here, but still in the green. And finally, if we go all the way to Ocean View, we get some non-zero numbers. You can see we're popping into the yellow occasionally still. So it's not like it's gone away entirely. It's still there a bit. But it's not nearly as bad as it was, I showed you guys last week here. South Kona for comparison to. There we go. So just barely coming into the yellow ones. And yellow is not the be-all end-all. There are times where it's higher and times where it's lower, obviously here. So lesser VOG impact is the main point here. And that means that viewing in a park has also been favorable. Not just the elevation of the lava and all the angles, but the air quality has been a little better as well. So here is the current view of wind direction blowing off to the southwest. Everything's in the green park. Let's go to the charts and we can review the last day here. Green, 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 all the way down. And nothing to really note there at all. So that said, we will transition into our lava viewing report here. So that is the next thing people are interested in for Kilauea. So lava viewing. Here's a map of the park. Park entrance up here. 3 viewing sites. Wikahuna, where you really can just see that east side of the crater floor, which one lava is oozing up. Has been good, but no ooze up flows in a while, so not as recommended nowadays. You can see good glow from there and beautiful vistas, but if you're looking to look at the lava surface directly, then you're not going to see it from there. Not to say it's not worth going, it's just different. Kupina Ipali, near the main visitor center. Wheelchair accessible over there. Half mile out, half mile back. Continues to have good views as well. And finally, Devastation Trail here in the south, where you walk to Kinakakoi Overlook and from there get a view into the crater and a lava lake directly as well. So, oh, that is very strange. All right, my video came up sideways. Let me see if I can reload it here because I don't know if that's happened before. Just try to reload it.
Live streaming, sometimes you get the weirdest bugs.
I've never seen that happen before.
Yeah, that's a new one.
How you fix that? So let me do this. Let me go back to here. For this one. Oh, that one's changed sideways too. All right. Well.
Really weird. They really wanted it to be vertical. Like they think it's TikTok or something.
Let's see. I'm gonna make this work. Back to this one. I'm gonna pull a different version.
Let me see.
Force it to reload here. There we go. All right, so there's a view from the overlook. zoomed way in, showing that spattering on that southwest part of the lava lake. This crust is all moving, but when you're looking at it live, it's just kind of creeping along. It's hard to really see that this crust is actually flowing this direction. So I sped the whole thing up from pre-dawn. There is that spattering spot that was just zoomed in on over there. Up here, you see the glow of the west vent cone. The west vent pond is back over here. Don't see it glowing in this sequence, but occasionally you would see it glowing. And here comes dawn, so you start to see the landscape a little better. You see that crest moving from that exit point, still coming over. And there is that sink we saw over here, one in here, and then one over here on the right as well. And so actually, I want to rewind this a little bit. Just because as it gets light, I want to zoom it in here. I want to show you guys this entry point, right? So the lava level is dropped down a bit from where it used to be before that crust sagged. And you can see there's that little lava tube visible here. That was that exit point. Lava from the west vent. Oh. Back here. Lava from the west vent coming around the pond and back in through. So, right, I think that video is at its limit. I'm not going to mess with it anymore. We'll move on to the B1 camera, which is a similar view. So really zoomed in way into there, that last view, but this is what you might see with a naked eye from those overlooks, Kanakakoi. Similar view to this. And as you can see, it's not just the lava, but the whole landscape is steaming and fuming. And Dane pulled out this nice image for us. Sunset capture here showing the hornitos, spatter cones, and really fluorogenic steam here. So pretty cool stuff, and just a reminder of how much there is to see in the park. Good viewing continues is the bottom line. So we'll move on to our observations, and that's going to be our webcams. Here's a KW camera, day and night for the last week, and just lava and a persistent lake circulating through here. There's a vent and pond and vent, and really no ooze up flows anywhere on a perimeter like we used to see in the previous months here, right? So it's still coming in below and lifting the entire crater floor. We're not really seeing much of that visible here in this last week, but as time marches on, we'll compile those animations for you guys as well. Here's a thermal view from the F1 camera. More easily see that glowing west vent pond, and a west vent over here. Here's that southeast pit, and it's still overturning, lava still going through that little passageway through there. And otherwise, circulating as normal. Not a whole lot to see there. It's been fairly steady with level within the pit there. Our main signal on Kilauea has been deflation-inflation cycles for the last few weeks here. And that has essentially led to no or very little net gain in lava depth here. So lava depth is pretty similar to what it was a week ago. It's changed between then and now, but it's ended up more or less at the same place after all the time. Come back to that when we get to our signals. Here's an S1 camera, so similar story. You still see glow around that edge of the crater by that central island, and everything else is as before. Run through it and document the visual observations here for the last week. One last webcam is the V1 camera, zoomed into the lava lake itself. You don't see the lava level changing a whole lot, you just see day and night and circulation. It's still flowing in that direction as usual, nothing's changed there. And beautiful, but nothing really stands out noteworthy to highlight here today. So those are our visual observations of Kilauea, and we will move on to monitoring data from Kilauea. There is our summit lava depth chart for the last week. We start off at about 372, close to 372.2 here, the left end of the graph about a week ago, and we end up here at the right at 372.2. Clearly it's gotten up and down a lot, and generally up and back down and back up again. That's following this pattern of the tilt. There is a summit tilt, and you can see little deflation-inflation events here, two little ones, and a bigger one that we're just coming out of right now. This latest one is about almost 3 microradians of offset, whereas this previous one here was about 1. Right? So we really got to zoom out. Let's go back to the last month and scroll it down so you can see the tilt here as well. Here's the last month. There's that bigger deflation-inflation, and there's the smaller ones. The bigger one matches the previous ones we're having as well, so it's we've had little ones and big ones and kind of intersperse and irregular, and that pattern is continuing here as well. The lava depth for the last month, you can see all of that, right? It was showing these variations, deflation, inflation as well. And then really following that rise, and really the last week is just through here. So that's where we have had less gain, right? And part of that is because of what I pointed out at the top of the hour here. The overall pattern of tilt that I was rising and was offset by flank motion right here, right? When we say offset, I'm showing you guys the line. The tilt actually swayed and then swayed back. It parked itself offset from where it was from some distance. The last time we saw this was when we had an injection of lava underneath the summit, that intrusion, and that showed that the actual ground had shifted and stage shifted. And so you could consider that possibility here as well, that the ground actually shifted and stage shifted because of that flank earthquake. Everything adjusted. Like the whole soft flank is like a big accordion, right? Lots of little crinkles in it. So when you have one edge of it move quite a bit, you can actually move the little crinkles a little bit as well, and that might be one possibility of how the ground could have moved all the way at the summit, influenced by that flank earthquake. And you see that the pattern from before keeps going, it goes up a little bit, but really about a week after that flank event, and it's not quite clear if this is exactly related or not, but you see from that point on until now, we've had deflation of the volcano, right? Now, one possibility is that if we moved some of the rock on the flank and made more room underground, then it can't pressurize as much. It's not going to swell as much. It could actually come back down, but that's a limited amount. It's that much actually, right? So you could suspect that after that much deflation, it might pick back up again. So we'll be curious to see here if this continues going upwards in the future, or if it stays going downwards. And if it stays going, if it goes back up, then you might suggest that this was a temporary adjustment following that flank movement. And if it keeps going down for longer, then you might say it's something more independent, or triggered something independent, or it just happens to be a coincidence that happened at the same time. A little hard to untangle those things, but those are the possibilities there with that. Yeah. But interesting to note that as we look at the SO2, here is our 700 ton per day plot data point that comes in right in here, right? So while we're having deflation, we're also having a lower gas value, right? Which could be consistent, but then again, you're also having deflation inflation cycles. So, and the caveats we mentioned before, maybe the gas is getting dissolved in the magma below the crust, and it's hard to really catch it all or measure it all or those kind of things. And so we'll have to wait for more info on that. But there's an interesting association there at the same time of having a low gas plot to have this deflationary trend. So big picture, there is that small drop that occurred September 20th with that little sagging of the floor of the Ma'u and intrusion below. And the pattern is still that on a large scale. Here's our 1 year GPS, north to south across the summit. And if you'll look, we're actually not getting data in here. We're having a little bit of data gap, but most recently it was showing the same kind of trend. If we go down to the East Rift Zone at Pu'o'o, we can see that down there, we are still showing a downward trend, contracting maybe slightly less quickly than before, but still a contractional trend, as you see on the middle East Rift there. Now, to kind of dig into this a little bit more, let's go and look at the GPS stations independently, at least the summit ones. Here's summit stations, and looking northwest at Wikahuna, it appears that it's also missing some data a little bit here at the edge, right? Remember, this is a 2 year plot as opposed to 1 year, so it's going to be a smaller gap, but there still is a gap. And so it's probably just some data logging to the website issue going on here, right? You can probably expect that to recover here in due time. And really the patterns haven't changed that we can tell, right? Here's long-term Kilauea was going up. It'd be interesting to see if this turns around with a tilt or what, but all of that's not going to show up until probably a week or two from now anyways. Down at the Crater Rim Station, data is still coming in, and you can see similar patterns as before. Maybe the up, it's flattened a little bit there. Hard to really tell. Not a whole lot of obvious change in outlet. For Byron's Ledge, we saw some wiggles last week, but that trend that looked like it might have been coming down seems to have resumed, and it just shows you the scattered and small scale adjustments that are possible to see within this data and not know what they are when you're seeing them for the first time, right? So that's the summit. Elsewhere in the volcano, we really don't see a whole lot that's noteworthy here on a GPS. So I'll move on from that. Let's come back here to this. Actually, what I want to show you guys is this once again, right? This plot that we showed came out of the Maunaloa community talk. It was comparing the relative size of Maunaloa's motion as shown by GPS to Kilauea's. So let's ignore Maunaloa now, and let's look at Kilauea, and let's actually start all the way down here at the East Rift, and you can see that these stations that are up where the base of the arrow is where the station is, they're all on the north side of the rift, are all pointing back towards the rift, showing sagging. So this, you really can see that everything over here is not really, it doesn't seem to be currently active as far as the East Rift, right? It's kind of sagging and contracting, really. Right? Down here, the south flank, this part of the south flank is moving. You see a little bit, this point way over here must be on a lava flow, close to lava flow, so you can see some movement, adjustment, of settling of that, perhaps. And coming further over, you can see, first of all, summit radial pattern, everything going out, large magnitudes. That's the swelling of the summit with magma from Kilauea. Even as it's filling that lava lake, it's been bulging underground. We've been saying that for a while and showing the graphs. It's cool to have this plot to show you guys a different way like that. Apart from that sector, let's look at the south flank here, the south flank south of the summit. This whole area all through here, that whole zone, see, is all moving to the south. Typical vector there and there, right? So south flank is moving to allow that summit to fill as well. And then we've mentioned this before. This funky zone right over here, right by the bend of the East Rift Zone, has really got some weird stuff going on. Some of the stuff is moving this way. Some of the stuff is moving this way. Some of the stuff is moving this way. It's almost like it's spinning in some ways. It's kind of getting caught in some little vortex in there, right? So that's an adjustment because the East Rift from Kilauea starts with this upper East Rift connector, and it takes a bend going off in that direction. So you get some, you might have some weird interaction between the south flank that's south of the summit and the south flank over here that's south of this middle East Rift Zone, and then the south flank by the lower part that's not moving at all. So that thing is getting pushed on this side and it's getting held up on this side, and maybe that's why it's doing something weird like that. If you were looking at the Kalapana Tro station that we'd like to follow, that's that zone of weirdness going on in there. Okay, and one last thing to cover in our monitoring here, and that's going back to the tilt plot. This is a tilt plot I captured last week, but going back to the signal back from November 20th, where we saw the tilt signal come up and then stabilize, right? And we talked at the time about how this was likely an offset because magma had injected underground and stayed there, rather than earthquake signal where we see it kind of come up and bounce back down, right? So in this case, you see, when I was talking about instantaneous before, you see there's actually a little jog right in there. That's showing us it's not a straight instantaneous line, but slightly slower process there. And the magnitude also gives it away a little bit different, right? So that's that suspected intrusion there. And having brought that up, we'll switch gears and pull up USGS Weekly Volcano Watch. And Volcano Watch that we're showing you guys today was published on Friday, after our most recent update concluded, but addressing that inflationary issue there. Right, so we'll cover it today. We'll bring you guys Volcano Watch from tomorrow, next week as well. Catch back up with that. So a couple of things that this article talks about. It's kind of a 2-for-1. Title is a year of continuous eruption at Halemaumau, close but not quite. And that's because there have been pauses, many pauses in that surface lava lake that occurred, especially in the first few months of eruption. I won't read all of this. This has been posted on hawaiitracker.com for a while, so you can go catch that if you like. But the last pause to date was March 18th, and since then it's been mostly truly continuous lava effusion. Before that, we're getting those pauses, and some of the pauses, well, all the pauses were associated with big deflation inflation events. The ones that happened before that and the ones that happened after that did not cause those pauses, and so that's kind of the question that they're putting out there and leaving it hanging. It's not quite clear exactly why that's happening. We've discussed before the whole idea of how open a conduit is and how we saw it change it's the delay to being no delay, and maybe something was stuck in a conduit, but that's all speculation, really. Just trying to find some explanation for what the data is, and they're digging into it a little bit more precisely here, and they're still just sharing that work is ongoing. So that's kind of part one, and the two-parter. The second part here is this intrusion bit. The activity was disrupted one more time, September 20th, when a swarm of several dozen earthquakes occurred beneath Haleakala. Simultaneously, tiltmeters measured rapid inflation in the summit region, and at 4:30 p.m. webcams recorded the higher part of the crater floor dropping by several meters at the same time as breakouts occurred in the lower margins of the crater. Earthquakes and tilt soon tailed off, followed by the return of activity within the lava lake. And this is not a surprise to you guys if you've been following us. Initial observations suggested the conduit to the vent may have experienced a structural failure, allowing dense lava below the crater floor to infiltrate the conduit and causing it to clog. However, physical data from this event and the following days tells a very different story. Insar data from satellites show an area around the west side of Haleakala crater, uplifted by a couple centimeters around September 20th. So that's the new part right there. Insar data is, they're not showing us, but they're telling us, shows a couple centimeters of uplift around the west side of Haleakala crater. Modeling as seismic information indicates a horizontal body of magma called a sill may have intruded between old layers of lava below the crater that day. The fact that summit inflated on September 20th but never deflated in association with the new lava breakouts is consistent with the accumulation of magma somewhere below the ground. Drop of the crater floor suggests a possibility that some lava may have drained back down a conduit to form part of the sill as well. And so we'll continue collecting and to learn more all from that. But this was the prime candidate to explain what we saw on the data, and we shared that with you guys. I think it was the day after even. And here it is. So far, so good. That initial best educated guess is being supported by their modeling. And that's the volcano watch for last week, actually. So there's only one more thing to step through for us this week, and that is the earthquakes on Kilauea. Kilauea's recent earthquakes, you can see here is the last year. Really low value still, nothing's really changed. Here's the last month. It's all about the same. Earthquake values have been a little bit high in some days, especially at this day, the 21st. You see a little spike right there. It's a little bit higher. Got not quite to 70 earthquakes in one day. If we look at the map for the last week, here it is. Let me zoom it in so you can see it. There is that south flank area, these very, very small dots, as very small earthquakes showing continuing movement at the flank. And really what's a little bit new this week, is this cluster up at the summit. And it's kind of a cluster right under Kilauea and a more broader zone around the whole summit, really, altogether. And we'll look at that here shortly, but just to kind of get through the rest of the map, here is Pahala still showing the deep earthquakes. In this particular image, the earthquakes are colored by depth. Right? So red is shallow, orange is just below, and then it goes yellow, green, blue, purple. Purple ones are the deepest ones you see down in there. So it is in cross-section for the last week. If we pull it back to the last, so here is depth and time. Right? So if we're curious when those earthquakes occurred, mostly, you can see here's the 21st. There's that cluster, so that spike on a monthly plot corresponds to this cluster that's likely up here in the summit, around summit in Kilauea as well. So a little bit more adjustment happening at the summit there. Pretty minor, really. Here's a whole last month. And looking at that, it gives you a little bit more of the long-term picture. So over the last month, you actually have a good amount of earthquakes at the summit of Kilauea, right? So things are still adjusting, moving, lots of little micro-quick activity happening over there. Adjustments as magma is redistributing underground and it's working its way to the surface and trying to push that crust back up to refill and repair the sag that occurred more than a month ago now. And I'm not sure how well this will be visible for you guys, but this is a cross-section for the last month. So there is a summit events, kind of a little shallower, showing some red right in here, and then the south flank is off to the side, slightly deeper. It's hard because the scale is so compressed here on the side, but we'll leave it at that. Looking at Kilauea, let's go into a little more depth here. Here is the last week of earthquakes on the main USGS map. And as you can tell, there's not nearly as many events showing on here, showing that many of those were small events that are not meeting the threshold to plot on this map. Of the ones on this map, I have them listed only by what's on the map, and the largest magnitude first. The largest one was a 2.7 underneath the northern caldera floor, right around sea level. This one's also close to sea level, 2.4. 2.1 over here, not far from the volcano village. 2.1 on my Kilauea Iki. So this is where that larger cluster is. 2.0 out here towards the Southwest Rift. 1.9, 1.8 are the other two that are on the map there. So if I zoom this out, you can see really not a whole lot showing up on this map. Doesn't really compare to even this last week that we see right here. Scroll smoothly. Right, that's what we're comparing it against, is that image. So showing a lot more. And this is why we look at multiple ones of these maps. Really not remarkable, but that's interesting that those are happening. I'm going to pull back into the tilt briefly here, right? So here's our Kilauea tilt. Mostly 1 month tilt. This is Uikahuna at the top. Let's skip through that. And here is 1 month at Uikahuna. And this is actually showing last week. Let's get it. There we go. Uikahuna for the last month. We looked at, there was Sand Hill showing, we're zooming in similar patterns. We're not getting signals from other places. The Escape Road is a tricky spot always because it's affected by both the summit and the upper East Rift connector. But you see there's a little bit of movement through there, and the thing is, we've been seeing activity within the upper East Rift connector for a while already. We've talked about how prior to the eruption in 2020, magma was filling all the way to Pu'o'o apparently. When the eruption began, the magma backflowed from the East Rift into the summit region and fed that eruption. It seems like since that intrusion occurred about a month ago, we've had more activity through that upper East Rift connector as well. So we know it's been active, and it's just curious to see like what might be happening, seeing those earthquakes Kilauea Iki. So moving over, get all the way to Pu'o'o, and here's a POC tiltmeter. That's showing mostly a downward trend. You see that one earthquake spike in the middle here as well. But it's a little interesting. If you get here to right around the 21st, you see a little rise come in, and it goes back down again. Right? It's a very, very, very small thing, showing maybe it's feeling the effects. This is a fraction of microradian here, right? But if you imagine that the magma is having to move down this East Rift connector, then make the bend and come around, right? If you have the magma actually trying to work its way around this corner, you might expect to have pushing going on and earthquakes in this zone and possibly some small tilt signals. So nothing major, nothing new. It's really just showing that there is some little activity happening through there, and it's probably because we see magma coming into the volcano from below. It's filling that whole area underneath the summit. It's filling up into the lake. It's intruding. We saw that last month, but it's also going down that upper East Rift connector and trying to use that part of that magma reservoir system, right? I've talked about it before. It's almost like you have a heart and arteries going out, and the artery is just well connected. So it's really a part of the heart. It's part of that main magma reservoir system all the way up. I mean, this whole summit region through here. It kind of goes into the Southwest Rift a little bit, then it goes in the Southeast Rift a bit also. So it's really something like that's really the shape of that magma reservoir underground there. And you could argue that there's blades coming in over here too that kind of connect the whole thing and finish it off, right? So that's the overall pattern. And small kind, just as we track Kilauea here, and for those of you guys that have made it this far in our broadcast, but I'd drop that little nugget for you guys there. So to finish it off here, cite our sources. All this is data that we're compiling and synthesizing from the USGS Hawaiian Volcano Observatory. Most recent update today, Kilauea. It's still erupting. It's the volcano that actually is at alert level watch and aviation orange, but no significant changes in the summit or in either rift zone, right? They're really specifying that area, Pu'o'o and beyond, right? So that's with respect to where people are and where the hazard is. So no increased threat to people is the bottom line there, regardless of this little trickles of signals we see here on this rift connector. That is it. We don't have any more data as far as depth, as far as anything else here. So That's our source, and mahalo once again to the USGS. Everything presenting is courtesy of them. All right, Dane, let's wrap it up.
All right, we'll go through one more segment of questions. How about?
Yeah.
Mariah asks, could the VOG decline mean Kilauea is losing steam because Maunaloa is acting up, filling up?
If the pattern that we saw had just begun declining recently, maybe it might be more convincing. But it's been declining since the start, and in fact, every eruption has this declining pattern. That's how they often go, right? It starts off really, really high, and then it tails off, and it tails off a little more and a little more. So, my initial instinct is probably not. However, the question really is getting at what's the connection on Kilauea and Maunaloa and how are they affecting each other a little bit, right? So, I mean, we did see the effect of the Maunaloa flank earthquakes on the tilt, and I think that's more convincing that was a signal, right? The gas is, I'm a little less sure on that. Long term, we think that Kilauea and Maunaloa like to take turns. If the magma supply is not really, really robust and pumping. However, given the cluster of earthquakes in Deep Pahala, activity at Kilauea, and swelling of Maunaloa, we may be in one of these extra magma coming from the hotspot eras. And so it's totally possible that, like in 84, or in like 2002 to 2005, that magma came into both volcanoes at the same time. That's totally possible as well. So they can play off and kind of one back off when the other one is not. But that's secondary to how much magma is coming in from below. Magma has to be below a certain threshold, which we don't know exactly what it is. We just kind of look at the patterns and generalize. And it seems like that's not quite what's happening right now. And we'll wait and see, right? Maybe after the fact we'll think differently.
All right, Kenny asks, sort of wondering if we are starting a long-term deflation trend on Kilauea, maybe a pause or into the eruption? Question mark.
Could be. Question mark. Yeah. I mean, it's only been deflating for a week. Not quite.
Right.
We'll wait and see.
Yeah, let's see if that trend continues. Right. Richard asks, about going back to the chemistry and kind of relating to the previous round of questioning. Richard asks, how does Loihi, or the volcano formerly known as Loihi, chemistry compare to Maunaloa and Kilauea's chemistries?
Similarly, broadly very similar, with those trace differences that give it a unique fingerprint. Kama Ehua Kanaloa is its new name.
All right, good. And finally, the last one I have here is, Kenny asks, could deflation be a warning for a bigger blob coming in through the system?
Yeah, that's interesting. Sometimes that does happen. You know, it's like I think of it like a lava lamp, right? You might have distinct blobs, and like one kind of tails off before the next one starts coming up, and it could be. I mean, I don't know if I'd call it a warning. It could be a signal, right? Because magma's been coming in for a long time. Yeah, that's what it does at this volcano. So something big enough that you might require a warning. I don't think that's coming. I think it's more just the regular variation we see, right? And it could be that there's a different batch or something like that that's coming through, or something that interrupted the flow below, or something along those lines. And yeah, those are interesting things to think about, but there's really no hard answers there. But yeah, interesting thought experiments. And I like how Kenny's thinking about all these possibilities, and I think about all these possibilities as well, and I like to generalize, but can't really give an answer there. We can just discuss these questions.
Right. All right. Well, I think that does it for our questions. Just like to remind everybody that there is a civil defense and USGS presentation, the second round of the status update and community discussion on Maunaloa. This one will be taking place in Pahala, 5 p.m. That is why we're coming to you live today, that scheduling conflict. We will be there, and we'll be able to talk with anybody that shows up, wants to talk any kind of details about the volcanoes, as well as a bunch of people from USGS and from state, county. Somebody's going to be there going to be able to answer your question.
Yeah, for sure.
Yeah.
And there is another meeting that I'm not sure when it is going to be yet, but it's going to be in South Kona, a third
Right.
of the same meeting, because Mauna Loa is big. Not everyone can
Yep.
make it around, right? So the first one was Ocean View last week. The second one is Pahala this week. I would expect South Kona next week. They could pick Thursday at 5 again, so you guys might have to stay tuned to see if that happens to be. We'll see what happens next
Right.
week. We may have to adjust the schedule once again, not because of the volcano. Just telling you right now because of the schedule that we're not quite sure about that. We want to make sure that we also reach out to each of those communities in person and connect them online. So we'll be there as well.
So with that said, we will be back tentatively next week on Thursday at 5 p.m. With our standard update, unless we have to change it, of course. But yeah, we'll be back next week Thursday. And unless something changes, right? Something actually does happen, and then we will go live to cover that and get you whatever information that we can get on whatever does happen. We don't really expect that, but hey, you never know. We live on, a lot of active volcanoes. So I believe that wraps it up for me. Thanks everybody for sticking around in the chat. Make sure to like, subscribe, share, all that jazz. It really does help with the algorithm. Make sure it gets out there so more people can see, information instead of hype. And that's really what we're about. Try and get, real information out there. We'll talk about the worst case scenario. We're not going to hide it, but we're also talking about most likely cases as well, right? The probability aspect comes in. So with that, I will sign off and pass it to you, Phil.
Yeah, mahalo, Dane. Yeah, be prepared and be a little worried if it helps you be prepared, but really don't be too worried yet. There's a long process of ramping up if it's going to actually lead when it leads to an eruption eventually. We will be there every step of the way, as we have been every week when nothing was happening. We were here too, so we'll still be here for times when it is.
Don't panic. That's always been one of my big messages. Panic itself is a huge danger. Just get a little bit informed so you get comfortable, and that might be the difference right there for you. Just that little bit of comfort to prevent the panic from happening so you can make rational decisions when you need to.
Yeah, be prepared, be informed, and clear-headed.
Right.
Yeah, and clear-headed now. Hopefully that's clear. All right, you guys. Mahalo once again from HawaiiTracker.com. He's Dane DuPont. I'm Philip Ong.